everyone, welcome back to Diksha Karnataka YouTube channel, and today I am going to discuss a very important 100 MCQs, chapter wise MCQs. Also I am going to tell you from which chapter you can expect what type of questions, like a HOTS question. This chapter important for HOTS question, how many questions you can expect from this chapter. So everything will be explained in detail in this video along with total 100 MCQs. So without any delay, let us start with the session. First is obviously the first chapter, electric charges and field, and in this chapter you can expect maximum one MCQ, not more than one MCQ from this chapter, and there is no HOTS question coming from this chapter. So obviously electric charges and fields is very important chapter. So let's look into the questions from this chapter. The dielectric of electric field vector at a point on the equatorial line of a dipole is. Okay, so in the same direction of dipole moment, in the opposite direction of the dipole moment, towards the negative charge, away from the positive charge. So electric field vector on a line on the equatorial line. So equatorial line means, as we know, if this is the dipole plus q minus q, then definitely dipole moment is from negative to positive, whereas electric field is from positive to negative. So electric field will be opposite to that of the dipole moment. Now you might answer, sir, why not it is for the negative charge? Why it is not towards the negative charge? Because equatorial plane is a plane, so not always it will be towards negative charge. So you cannot generalize it like that. So you have to mention that it is opposite to that of the dipole moment. So the direction is in the opposite direction of the dipole moment. Option B is the correct answer. Now I have a tendency, sometimes I answer it correctly and later on I mark it a wrong option. So if you have any such discrepancies in my videos, don't forget to mention that in the comment below. Now let's see, here we have following figure shows the electric field around two charges where so we have two charges, Q1 and Q2. As you can see, both field lines are going in the opposite direction. So field lines going in opposite direction means that both charges are positively charged, because no field lines is coming towards the charge. So if the field lines are going away, then definitely it's a positive charge. So both charges are positive. Okay, both charges are positive. If for one charge it was going out, whereas for the other charge it was coming in, then it would be a one positive, one negative. Now, which of the following charges is not possible? Okay, so this question is based on the quantization principle. So as you can see, this is a integral multiple of charge. It is itself is the charge E. If you see, this one will be 2E. If you see, this one will be 4E, but this one is not 3E. Okay, 316 the 48. So 4.8, it is 5.6. It is actually 3.5. Okay, so this is 3.5, which is not possible. So definitely this amount of charge is not possible. So correct answer is option C. So be careful, as we know that all the charges has to be integral multiple of charge, basic charge E. So they all has to form have the integer value at the beginning. If there is no integer value, then definitely this is not possible. So this is a very interesting question. Now let's move on. Name the physical quantity which has a dimensional formula LTA. Okay, line charge density, capacitance, dipole moment, charge. So what is LTA? L is dimension for length, T is dimension for time, and A is dimension of current. Now if you remember that A into T is the dimension of charge. Okay, A into T is dimension of charge, right? Current is basically Q divided by time. So charge is basically current into time. So its dimension is T into A. Now what is the dimension? L represents distance. So if you multiply distance with a charge, you get a quantity. If you remember this, then this is basically a dipole moment. So this is an unit of dipole moment. Okay. So a very basic question. If you don't understand it, try to break it down if possible, okay, and then you can figure it out what could be the possible answer for this question. Now, dash placed in an electric field experiences a force in the direction of the electric field. An electron, a negative charge, a proton, both A and B. So when you place some charge, we always know that when you place a charge in the electric field, the charge experiences a force in the direction of electric field if the charge is positive, okay, and if the charge is negative, then it experiences a force opposite direction of the electric field. Here it is said that in the direction of the electric field, in the same direction of the electric field. So what should be the charge? The charge should be positive charge. What is the given option in this case? Is a positive charge. So if you see electron is negative, negative charge itself is negative, so only proton is a positive charge. If you place a proton in the electric field, it will experience a force in the direction of electric field. So answer is a proton. Now, next question. When a free electric dipole is placed in an uniform electric field, the dipole will experience both force and torque. Only force but not torque, only torque but no force, neither torque nor force. Now this is a common question, but the question language is changed here, so don't answer questions without properly reading it, okay. There is a question where the answer is basically both force and torque, but in this case it is not. Why? That question where it is mentioned both force and torque is basically non-uniform electric field, but in this question the language is changed, it is uniform electric field. So that is why this question was given to trick you, that all the teachers, I have myself has done this MCQ 2-3 times where non-uniform was given. Now they have given you very easy version, that is uniform electric field. Now in uniform electric field only torque will be acting but not the force, okay. In non-uniform electric field both force and torque will be acting. In uniform electric field only torque will be acting, no force will act. So be careful, read the question more than once, make sure that your answer is correct, okay. Now let's move on. SI unit of electric flux. So what is electric flux? If you know the definition of electric flux, you can answer it. Electric flux is basically electric field into area, right? Electric field into area. So what is the unit for electric field? Electric field is Newton Coulomb and area is meter square. So Newton Coulomb meter square is the answer, not Weber. Weber is the magnetic field unit for magnetic field. So don't fall for the trap that maybe Weber will be the answer. It will be Newton per Coulomb into meter square. Sorry, the small mistake is here. So Newton Coulomb per Coulomb meter square. Okay, so electric field is Newton per Coulomb and area is meter square. So Newton per Coulomb meter square is the answer. So correct answer is option C. Let's move on. As you know that we have currently going through upcoming KCET 2025 exam preparation. So one best way to prepare yourself is to participate in the Abhyas KCET 2025 test series, which is available exclusively via our app. The link for this registration is given in the description below, and right now the price is 1499. That includes your PU2 test series. If you don't want PU2 test series, then 1498 is the current price. You can click on the link below and register yourself for 4 free test series, which is already available. If you don't want the 4 test series, you want the paid version, then you can register right now, pay the money, and from 17th of March onwards, once your all the main subject exams are over, you will start getting the question papers for your KCET 2025 exam. Okay, so let's continue with the next chapter. chapter. Next chapter is electric potential and capacitance. This is a very important chapter. Maximum up to 2 MCQs you can get from this chapter, and all this analysis is done from your 3 blueprints. Okay, previous 3-year question paper does not matter because the blueprint was different, the question pattern was different. Now the question paper is changed, the blueprint is changed, so you have to be careful about whatever others are saying. Okay, this chapter is supposed to be easy. Maybe that was easy because they had a different blueprint last year. Now here you can expect that 1 to 2 questions will come from this chapter, and 1 out of 3 blueprint is saying that there will be a HOTS question from this chapter. Okay, so there is a probability that there will be a HOTS question from this chapter as well. So 1 by 3 means you have 3 blueprints. Out of the 3 blueprints, 1 of the blueprint is saying there will be a HOTS question from this chapter. Okay, so let's start with the chapter the question. So there will be some easier questions, some HOTS question as well from this chapter, because we cannot skip HOTS question. This is a important chapter for HOTS question. Equal charges are given to 2 spherical objects of same radii. Okay, one a spherical shell, another a solid sphere. The potential at the center of the 2 spheres. So this is an interesting question. We have 2 spheres, both have same radii. Okay, same radii, say capital R, but one of them is solid, another one is a shell. Okay, and they are given the same charges, equal charges. So if this is given Q, this is also given Q. Now what will be the potential at the center of these 2 spherical objects? So as you know that the potential at the center is independent of the whether it's a solid sphere or a hollow sphere. It only depends on the total charge given in the system and the radius of the sphere, right? So it will be KQ by R for the potential at the center. Okay, so potential at the center will be KQ by R. It's a constant value. Inside the sphere the potential will be constant throughout the surface till the center. Okay, center to surface it will be constant, potential will be constant, so definitely it will be KQ by R. So both cases it will be same. Okay, it does not matter it is a sphere or it's a hollow sphere or it's a solid sphere, does not matter. It will be equal on both the objects. It will be equal on both the objects. Okay, so this is a semi hot question, not super hot question, semi hot question where you have to apply some logic. Okay, now let's see the another question. The dimension of electric polarization is given by. So what is electric polarization? So electric polarization is the dipole moment, net dipole moment per unit volume. Okay, that is the definition of electric polarization. So net dipole moment is basically what is the unit for dipole or dimension for dipole moment. We have just learned that in our previous part. It is L into A into T or LTA. Okay, whatever you mention, and divided by unit volume. Unit volume is L cube. Okay, so it will be L square, L to the power minus 2 T into A. Okay, so this is the dimensional formula for electric polarization, what remembering question. So it is a L to the power minus 2 A into T, but in case you forget, you can remember the definition of electric polarization, which is basically net dipole moment per unit volume. Okay, now let's move on to the next question. The electric potential at the surface of a charged spherical shell of radius 10 centimeter is 20 volt. The electric potential at the center of the shell is, so again this will be also easy question because we know that electric potential at the center of the shell remains constant. Charged spherical shell, whatever is on the surface, the same electric potential is inside the sphere as well. And in case of solid sphere also, if it is a conducting sphere, definitely the potential is constant. If it is a not conducting sphere, then at the center it will be the same value. Okay, that must be the constant, so it will be 20 volt. Okay, 20 volt is the answer in this case, right? Now the electric field at which the electric field at a point which is very close to the surface of a charged conductor with surface charge density sigma. So if it is a very charged conductor with the surface charge density sigma is given by sigma by epsilon naught. This is the formula that is given in your textbook. Okay, now let's move on. An electric dipole is placed inside an insulating spherical shell. Pick the wrong statement. Okay, so electric dipole is placed inside a spherical shell. So this is a shell and an electric dipole is placed inside it. Okay, insulating cell, it is an insulating material. Okay, net charge enclosed by the shell is 0. So we have to find the wrong statement. So net charge, what is the net charge? So suppose this is plus q, this should be minus q. So net charge obviously is basically plus q minus q, that is equals to 0. Okay, so net charge will be 0. So this is the correct statement. Sphere acts as equipotential surface. Okay, let's see, we do not know this question. Let us see that in a while. Electric flux through the sphere is 0. Electric flux, definitely the net charge is 0. That means electric flux through the surface should be 0. So that is also constant. Electric field is not uniform across the surface of the spherical shell. So electric field, we know that from Gauss law, this is a hot question. So Gauss law, we know that E dot ds equals to q enclosed by epsilon naught. So basically electric field is 0. So electric field will be 0. So 0 can be considered to be an uniform electric field. Obviously electric field is uniform, right? So definitely the sphere acts as an equipotential surface. This is also a correct statement. Okay, electric field, constant electric field means obviously it is a equipotential surface, and electric field is not uniform across the surface is not correct. Electric field will be uniform across the surface because electric field itself is 0 on the surface. If the electric field is here is E, then it will be 0 because net electric charge enclosed by the surface is 0. So from there you can calculate E is 0, and if E is 0, that means E is constant, then it will be an equipotential surface for sure, right? Now the following graphs show the variations of two physical quantities with distance r from the center of uniformly charged spherical shell. Identify the graph. So first we have one graph, we have a second graph. Now this graph, as you see that inside this, it is a constant. Okay, up to r radius this is constant, and here up to r radius the value is 0. Suddenly it is increasing, then going to 0. Okay, so this is, now as we know, this is a graph of electric field, and this is a graph of electric potential. Okay, so first graph shows the variation of V and R, whereas the second graph shows the variation of E versus R. So definitely option B is correct. So first you identify what the question is about, then from there you read all the statements, and from the statement, correct statement, whatever is the correct statement, identify it, make sure your identification is correct, then you write the answer. Okay, now next question. Statement 1, the electric field inside a conductor is 0. Statement 2, all the charges reside only on the surface of the conductor. Okay, so electric field inside a conductor is 0 because all the charges are residing on the surface. So both statements are correct, and because all the charges are on the surface, that means net charge enclosed is 0. So net charge enclosed 0 means electric field will definitely be 0. So both statements are correct, and statement 2 is the correct explanation of the statement 1. So option A is correct in this case. So if you see any statement based question coming in your board exam, which is most likely at least one statement 2 or assertion or reason based question is expected in your board exam, because they have given a lot of assertion reason question or statement 1 statement 2 questions, not only in your model question papers but also in the question bank they have shared. So there they have a lot of statement based questions. So there will be at least one statement based questions that I am expecting to come in your board exam. That is my expectation. Okay, even though in last 2 years there was no statement based question, but I am expecting there will be one statement based question this year. Okay, then all the statement based questions are considered to be HOTS question. Okay, now question number 15, an imaginary sphere of radius r is drawn around a charge q. So here we have a charge q and an imaginary sphere of radius r is drawn, keeping the charge q at its center. So keeping this q at the center, we have drawn a imaginary sphere of radius r. Okay, the work required to move a test charge from point A to point B. So we are trying to move a test charge q from point A to point B. Now, since the surface is a spherical surface, so we can say that the electric potential throughout the surface is constant. Right, it is a constant electric field. Electric field is constant, so potential will also be constant. So it is a equipotential surface. This is an equipotential surface. Also for a point charge, equipotential surfaces are spheres with the charge at its center. So from there also you can say that it is a equipotential surface. That means potential is constant throughout the surface, and work done to move a charge in an equipotential surface is 0. Right, so work done to move the charge in an equipotential surface is 0. So work done to move the test charge from A to B should be 0. As simple as that. Now let's move on to the next question. Next chapter, current electricity. Okay, current electricity, another very important chapter. From this chapter, one question will come, not more than one question will come, but there is a high chance that the question will be a HOTS question. Why? 2 out of 3 blueprints are saying that the question from this chapter will be HOTS question. So there is a high probable chance that the question from this chapter will be a HOTS question. Okay, so let's see the first question. In the equation AB equals to C, A is the current density, C is the electric field, then B is. This is a very common question, even though students often make mistakes. A is current density, J. Okay, C is electric field. Okay, so we can say that JB equals to E. Now, if you remember alternating form of Ohm's law, then you should know that J is equal to sigma E. J equals to sigma E. Right? This is a form of Ohm's law. Now, from there, if you try to find E, E is basically J by sigma. Now 1 by sigma, sigma is called conductivity. So 1 by sigma is basically the resistivity, right? So resistivity is 1 by sigma. So from there we can see that this B is nothing but this rho, that is resistivity. So this will be resistivity. Okay. Slightly tricky question. I think the same question is here as well. The relaxation time in conductors increases with the increase in temperature, decreases with increase in temperature. It is independent of temperature. Charges changes at 400 K and above. So relaxation time means, what is relaxation time? Suppose I have a conductor. Okay, an electron is trying to move from this side to this side. Now there are a lot of other electrons scattered across this conductor, right? So when this electron is trying to move from this side to this side, under the influence of electric field, or maybe just at as usual random motion, okay, it will always collide with another electron. Okay, the average time between two collisions is called the relaxation time. Okay, so average time between two consecutive collision is called relaxation time. Now as the electrons if you increase the temperature, the electrons will start vibrating with higher frequency, right? They will start vibrating more. Whoever was silent, they will also start vibrating, right? So more vibration means more number of collisions will happen between the electrons. So more number of collision means more often or more quickly the collisions will happen. So more quickly collision means the relaxation time decreases. Okay, so less time means decrease, right? So as you increase the temperature, relaxation time decreases. So relaxation time is basically inversely proportional to the temperature. You should remember that relaxation time is inversely proportional to the temperature. Higher the temperature, less is the relaxation time. Lower the temperature, higher is the relaxation time. Okay, now drift velocity of electron is due to motion of conduction electrons due to random collisions, motion of conduction electrons due to electric field E, repulsion to the conduction electrons due to inner electrons of ions, collisions of conduction electrons with each other. So definitely when you apply an external electric field, the electrons start to move in the opposite direction of the electric field. That motion is called drift motion or drift velocity. So motion of conduction electrons, and only conduction electrons can move. Okay, inner electrons or valence electrons, they cannot move. So definitely it's a motion of conduction electrons due to electric field E. Right, now question number 20. N identical cells of each EMF E and internal resistance R are connected in series. An external resistance R is connected in series with this combination. Then the current through R is. So how many cells are there? So N identical cells, EMF E and internal resistance R are connected in series. So definitely all of them are connected in series. Right, and there is an external resistance R. So first what we have to do, we have to find the total EMF and total internal resistance. Everyone has resistance, EMF is same. So how many EMFs are there? So net or equivalent EMF is basically N times E, right? E plus E plus E plus E up to N. So total EMF is N into E, whereas what is the total internal resistance? Total internal resistance is basically again R plus R plus R plus R, that is up to N times, so N into R. This is the total internal resistance. Now what is that? Now we have to apply Ohm's law. So Ohm's law says that V is equal to IR, so I will be V by R. Now in this case V is this one. Okay, V is this one. And what is resistance? Resistance is this entire sum of all the small resistances, that is this, plus the external resistance, that is NR plus capital R. So this is the current. Okay, so current is basically NE divided by NR plus R. So this is the correct answer, option E. Okay, let's move on. Statement 1. When a wire is not connected to a battery, then no current flows. So obviously if there is no source of electricity, there will be no current. Okay, in the absence of electric field, free electrons moves randomly or does not move in a particular direction. So obviously if there is no electric field, electrons in a conductor, they move randomly so that the net path cancels each other. So that is why no net motion of electrons. That is both statements are correct, and statement 2 is the correct explanation of statement 1, definitely. Okay, because only if the electrons move in a particular direction, then only we will say that there is a current in the circuit. But if there is no electric field, there will be no motion, that means no current. And electric field, who is the source of electric field? The battery. So battery not connected means no motion. Which of the following is different from others? So here we have given some units. We have to identify what type of units are these. Okay, so volt square per ohm. Volt square means, let's look into the formula. It is V square. Ohm is resistance, so it is in division, so V square by R. So what is this formula is about? This is the formula for power. Now let's see, ampere square ohm. Ampere square is current square, and resistance is ohm. Here it is multiplied. Again it's a unit for power. volt ampere, volt is V, ampere is I, so again it is a unit of power. Now joule second inverse is not unit of power, because unit of power is joules per second. Okay, that is work done by divided by time, that is joules per second, not joules per second inverse. This is a wrong answer. Okay, now this is an easy guess. All the units are given in units of current or voltage, but this is a mechanical unit, so maybe you will be able to answer that. But if they change something in the option and make this joule per second, then this is also same as this. This is also same as this. Okay, so be careful, this is a tricky question. Now another question, this question is from your model question paper. Okay, one of the model question, but I think model question paper 3 I have solved this question, but in that case diagram was missing. A wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which one of the following statement is correct? The drift speed of electron is constant. The drift speed of electron increases while moving from A to B. The drift speed of electron decreases while moving from A to B. The drift speed of electron varies randomly. So let's see how drift speed is related. So there is an area, this area say A, and this is the area B. Now you can see that area A is less than that of area B, right? This is clear from the diagram. Now we will try to find out what is the relationship between area and drift speed. So we know that current I is equal to NEA VD, or VD is equals to I by NEA. Now if you read the question carefully, that the steady current is flowing. Steady current flowing means I is constant. Now number density of a given metal is constant always. Okay, the electron charge of an electron is also constant, so all these three terms are constant. That means drift speed is directly proportional to 1 by A, or we can say that drift speed is inversely proportional to area. So higher the area, lower is drift speed, and lower the area, higher is the drift speed. So drift speed will be higher here, okay, and drift speed will be lower here, right? So from there we can say that drift speed will decrease. So drift speed is decreasing as it is moving from A to B. So drift speed of the electron decreases while moving from A to B. Okay, so this is the answer, easy question. Inversely proportional to area. If you remember, drift speed is inversely proportional to area, you can answer this question. Okay. Now next chapter, moving charges and magnetism. Even though it's a simple chapter, as you can see, one question you can expect, and there is a high chance that one question will be a HOTS question. Okay, so 2 out of 3 model paper is saying there will be a HOTS question from this chapter. Okay, so be prepared. The MCQ from this chapter tends to be difficult in historically as well. So let's see what type of questions is stored for us. When a magnetic compass needle is carried nearby to a straight wire carrying current, then the straight wire cause a noticeable deflection in the compass needle. Okay, so when you carry a compass needle near a straight current carrying wire, okay, it tends to deflect it, right? Now the alignment of the needle is tangential to the imaginary circle with straight wire, as it is center has a plane perpendicular to the wire. So basically what is the meaning of that? This is the straight wire carrying current. Okay, this is the plane perpendicular to it if you consider a circle, and if you consider the needle, so generally needle points in the tangential direction no matter where you have kept the needle. It will always be tangential to an imaginary circle. Okay, so both statements are correct, because electric field obviously is like that. Electric field lines are circular in nature, right? So because of that, it will be pointed towards the tangential direction. So both statements are correct. Okay, so both 1 and 2 are correct. Now these are not related to each other directly, like the reason and assertion based question. So if the same question was asked as a statement based question, statement 2 is the correct explanation, then there is no explanation. Okay, this is just both of them are observations, and both observations are correct, so that is why both statements are correct. Okay, so be careful what type of questions you are getting in your final exam. If a current is flowing in a straight wire parallel to positive x-axis and a magnetic field is there along positive y-axis, then the wire experiences force in the negative x direction. Wire experiences a force in the negative y direction, the wire experiences a force in the negative z direction, the wire experiences force in the positive z direction. Let's see, if a current I is flowing straight wire parallel to positive x-axis. So we have, suppose this is my x, y, z. Let me draw this way, this will be easier for me to understand. X, y and z. Okay, so current I is flowing in the x direction. Okay, and magnetic field is there in the positive y direction. So magnetic field is in this direction. So this is the current, this is magnetic field. What will be the force? So we know that current in this direction means electrons are moving in this direction with the velocity, right, some velocity. So we know that the force acting on this magnetic force is basically Q V cross B, right, V cross B. So if you, how to find V cross B, you start with your first, you would start your fingers in the direction of V. Okay, that is in the direction of current. Now if you start first and then what is this multiplied with? It is multiplied with B, right? So B means what you have to do, you have to put your fingers in direction of V, then slowly bend towards the second vector, that is B. Now your thumb will point the direction of the resultant vector, right? So you start with V because V is coming first, then you point towards B so that you get the direction of the ultimate vector. So basically the ultimate vector will be in the positive Z direction. So the wire experiences the force in the positive Z direction. Okay, clear? Now a strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of the field, remains stationary, moves perpendicular to the direction of the field, moves opposite to the direction of the field. So as you can see, most of the questions are not straightforward. You have to think twice before answering. Previous question, this question, if it is just what is the dimension, what is the unit, so those are remembering based question. But as you can see, these are not direct remembering based questions. So you have to understand it, that a strong magnetic field is applied on a stationary electron. So stationary electron means electron is static. So electron static means magnetic force will be 0 because it is V cross B, right? So it is V cross B along with the Q in between, right? Now if V is 0, then the force acting on this charge will be 0. So the charge will remain stationary. Okay, now if there is an electric field also there, then it will move based on the direction of electric field. So it will move in the opposite direction of the electric field because it's a electron. Okay, so but here no electric field is given, so it will remain stationary. An electron is projected, now this is the question that I was talking about. An electron is projected with an uniform velocity along the axis of a current carrying long solenoid. Which of the following is true? Okay, so along the axis of a long solenoid means, if you consider a solenoid basically have a constant electric field inside it. Okay, so the magnetic field is this, and you have projected you have projected an electron or charged particle in this direction, maybe opposite direction, either this side or this side. So what is the value of theta? Theta is either 0 degree or it can be 180 degree as well. So if it is going in the same direction, this is 0 degree. If it is going in the opposite direction, the angle will be 180 degree. Okay, so what is the force? So force we know that is Q V cross B, that is Q V B sin theta. right? Cross product means scalar term will be sin theta. Is it? Is it not? Now sin theta means what is the value of sin 90, or sorry, sin 90 no, sin 0 or sin 180. Sin 90 is 1, but here if the angle is 0, then sin 0 is 0. If the angle is 180, sin 180 is 0 as well. So in both cases, no matter how it is moving, does not matter, the electron will not experience any force. Okay, because the angle is 0, electron will not experience any force. So electron path will be straight. The electron will continue to move with a uniform velocity along the axis of the solenoid. So it will move with a constant velocity along the axis of the solenoid. Easy question. Not easy question, but you can answer it. The beams of electrons and protons move parallel to each other in the same direction. Then they will attract each other, repel each other, no relation, neither attracts nor repel. Now electrons and protons generally tend to attract each other in a static condition, right? Opposite charges attract, but in this case what happens is that an electron moving, suppose this is electron moving in this direction, this is a proton, okay, beam of proton, this is also moving in the same direction. So this is the direction of electron, this is the direction of proton. Now this is not simple, okay? In static condition it is simple, but when they are moving, there are a lot of things. There will be a magnetic field due to electron, there will be a magnetic field due to proton. Now based on their relative orientation, they will either attract or repel. Now if both of them are going in the same direction, we say that the proton can be considered to be a infinitely long wire carrying current, which is carrying current in the direction. Whereas electron, on the other hand, it can also be considered to be an infinitely long current carrying wire, but current will be in the opposite direction to that of the motion of electron, right? Electron in this direction means current should be in the opposite direction. So equivalent current due to these two charges will be opposite to each other. So opposite direction currents repel each other, right? Current in the opposite direction, they repel each other. Current in the same direction, they attract each other. So here, because the current directions are opposite, so they will repel each other. So even though they are electron and proton, the answer is not so simple. So that is why I say think twice before answering. If the questions appears to be very simple, unless and until is just a remembering based question. What is the unit? What is the dimension? Okay, if the question gives you a really easy vibes, check twice before answering. Okay, check twice before answering. A conducting circular loop of radius r carries a constant current I. It is placed in an uniform magnetic field B. Okay, so conducting circular loop of radius r. Okay, it is placed in an uniform magnetic field. Current is constant, magnetic field is uniform. Okay, such that B is perpendicular to the plane of the loop. So this is B is perpendicular to the plane of the loop. The magnetic force acting on this loop is, so magnetic force acting on this loop, as you can see that there is no direct relationship between the current and the magnetic field. Okay, so in this case magnetic force acting on this will be 0. Okay, so magnetic force acting on this will be 0. A charge q mass m is moving in uniform circular motion under the action of a magnetic field B. Charge q mass m is moving in uniform circular motion under the action of magnetic field B. If the radius of the circle is r, then the magnetic moment associated with the charge is given by. So what is the formula for magnetic moment? So magnetic moment is, there are two ways to calculate magnetic moment. One is current into I, current into area. Okay, that is one way. Now here we have charge q, mass m, moving in a uniform circular motion under the action of under the action of a magnetic field B. The radius of the circle is R. Now the magnetic moment is basically given by M equals to current into area, right? So this one we know. So this is little bit trickier answer. If you know the answer for this particular question, you can answer it, but otherwise it will be slightly trickier. So what we know, that current is basically charge divided by time. Now time is not given in this question, but area is given by pi r square. R is given, radius is given. Now what is the known values here? B is given, R is given, so magnetic field is given. So what we have to do, we have to simplify it for velocity. Velocity we need to find. Velocity is basically 2 pi r by t. So how we are going to eliminate time we can eliminate using the term velocity. So first we have to do this by q by 2 into 2 pi r by t into r. So this is the way we are eliminating the time t. So this is the velocity, right? So this becomes q by 2 into v into r. Now so answer is q v r by 2, but if you see that right, if I am not mistaken, yes, q v r by 2. Now you have to put the value of velocity in this expression. How to do that? We know that m v square by r equals to this is the centripetal force, and that should be equals to Lorentz force. Lorentz force is q v b by q v b sin theta, that is for theta equals to 90 degrees, it will be q v b. Okay, so from this equation you have to calculate v, right? Let's do that. So it will be one of the v's will be cancelled, so you get v equals to qb divided by qb r divided by m. Okay, now you have to put that value over here. So if you put that value, what you will get? You will get qr by 2 into qbr by m. So you get q square b r square by 2m. Okay, so q square b r square by 2m. So this is the answer. So as I said, if you know the answer, you can answer it. Now there is a tendency that student by default answer this one, because it is very similar to this one is very common expression. This qvr by 2 is very common, especially in competitive exams. This question has come in the past, so student think that, okay, qvr by 2, so I remember that expression, so qbr by 2 is the answer, but actually not. It is q square b r square by 2m. So this is the correct answer. That is why this is given twice. If you see in one case there is a 2 here, another case 2 is not there. So be careful if you see this question. This is a very tough HOTS question, and there is a chance that there will be at least 1 or 2 very tough HOTS question given in your board exam as well. Okay. Now again, a match the following type question. Match the physical quantities of column 1 with their units in column 2. So current sensitivity, in intensity of magnetic field, magnetic dipole moment. So let's see what all we know. Magnetic dipole moment, we know it is ampere meter square, right? Current into area, so ampere meter square. So magnetic dipole moment we know. So this one we will know, and we also know that the current sensitivity is division per ampere, voltage sensitivity is division per volt, so current sensitivity is definitely matching with C. So if you find two matching, obviously third matching is obvious, so it will match with A. So 1 is C and 2 is A. So 1 is C, 2 is A, 3 is B. So this is the correct match. Okay, as you see that only knowing one match is not sufficient, because 3B is given twice, 1C is given twice as well. But even if you are not able to do that, at least try to find two of the correct answer, then third one will obviously be coming. So option B is the correct answer, because it is matching with 1C, 2B, 3B and 2A is obviously a correct match, because even if you don't know that, third match will obviously come. Now next is magnetism and matter, another easy chapter. Here as you can see, one question you can expect and there is no HOTS question. So let's move through this chapter quickly. Magnetized needle placed in a non-uniform magnetic field in general experiences both force. This is like the dipole, but in this case non-uniform magnetic field is given. So non-uniform magnetic field means it will experience both torque and force. It will experience both force and torque. Okay, if it is uniform magnetic field, only torque, right? Force is only acting in a non-uniform electric or magnetic field. The dimension formula for magnetic intensity or magnetization. So magnetic intensity or magnetization, the dimensional formula is I think L into A. Okay, magnetization is what? Magnetization is magnetic moment per unit volume. So in case you forget, let's see that. So magnetization is I is dimension is area, sorry, ampere. A here A is area, that is m square, and you divide it by volume. So volume is again m cube, so it will be ampere meter to the power minus 1. So the dimension is L to the power minus 1 ampere. Okay, so this will be the dimension of magnetization. Magnetization, magnetic intensity, both are same quantity. So in case you see the question on magnetic intensity, then you should remember this is basically same as magnetization. So if the magnetization is given, this is easy definition, magnetic moment per unit volume. So from there you can calculate. But in case they give you magnetic intensity, that is H, maybe you get confused between this or this. So in that case you have to use the calculation ability to solve it. Next, the magnetic susceptibility of a material is 100. Its relative permeability. So relative permeability is basically 1 plus chi. So that is 1 plus 100, that is 101. Okay, easy question. For which one of the following substances the magnetic susceptibility is low and negative? So low and negative is for diamagnetic substance. So bismuth is a diamagnetic substance. First one, obviously oxygen is a paramagnetic substance. So iron is a ferromagnetic, sodium is also paramagnetic. So bismuth is an example of diamagnetic. So for it, susceptibility will be low and negative. The atoms in which kind of magnetic materials have permanent magnetic dipole moment? So permanent dipole magnetic moment is both for para and ferromagnetic. So option D is the answer. Next question, if a magnetic substance is kept in a magnetic field, then which of the following substance moves out of the magnetic field? Again, a diamagnetic substance moves out of the magnetic field. Let's see, semiconductors, we cannot say it's a diamagnetic or not. Paramagnetic substance, definitely not. Ferromagnetic substance, definitely not. Superconductors is an example of perfect diamagnetic substance. So superconductors are those who will come out of the magnetic field. Okay, so this is the answer for this question. Superconductors are perfect diamagnetic substance. The ratio between magnetization and magnetic intensity. So magnetization by magnetic intensity. Okay, we know that this is basically 1 by chi. Okay, H is equal to chi m. So m by H is 1 by chi. okay, is called permeability. No, it's called no, sorry, no, I made a mistake here. This is actually equals to chi. M by H is chi. M equals to chi M, chi H, right? So M equals to chi H. So this is not reciprocal of susceptibility, but it is a susceptibility itself. So this is a dimensionless quantity. The susceptibility is a dimensionless quantity. So from the given option, correct answer is dimensionless quantity. Okay. Next question, statement 1, statement 2. The net magnetic flux through any closed surface is 0. Okay, the number of magnetic field lines leaving the surface is balanced by number of field lines entering it. So this is basically the Gauss's law of magnetism. Both statements are correct, and statement 1 and 2 are correct, and 2 is the correct explanation for 1. So definitely this is a correct statement. Okay. Now next chapter is electromagnetic induction. As you can see, this is also very important chapter in terms of MCQ. You can expect up to 2 MCQs based on different blueprints. Some blueprints are saying 1 MCQ, some blueprints are saying 2 MCQs, and also 2 out of 3 blueprints are saying there will be a HOTS question from this chapter. Okay, so if there are 2 questions coming from this chapter, 1 will definitely be HOTS question. Okay, that much is sure. So let's see what type of question is coming. An electromagnetic induction, the induced EMF in a coil is independent of change in the magnetic flux, time of change in the magnetic flux, resistance of the circuit, number of turns in the coil. So induced EMF is equals to N d phi by dt. So it depends on number of turns, it depends on change in flux, it depends on change in time as well. So it is, but there nowhere you can see the resistance. So it is independent of the resistance of the circuit, right? Let's move on. An EMF is induced across the ends of moving conductor coil in a magnetic field. This is in accordance with Ampere's law, Gauss's law of magnetism, Faraday's law. So EMF is induced across the ends of a moving conductor or coil in a magnetic field. This is accordance with Faraday's law. In case the current direction is reversed or if they ask about current direction, then that is accordance with Lenz's law.
Will you upload in Drive, sir?
Okay. To be edited, I will upload. To be edited. Now let's move on to the next question. Question number 42. This is also very common type question. A similar question was asked in your model question paper. In the past, this kind of question we have seen in KCET exam as well. So as it is a difficult question, this is a HOTS question, right? Let's see the question. Direction of current induced in the loop ABC as shown in the figure. So here the current is given along ABC if I is increasing, along ACB if I is decreasing, along ABC if the I is decreasing, along ACB if I is constant. So first let us understand this diagram. So as you can see, the current is moving in this direction. So if you try to find the magnetic field, the direction of magnetic field will be into the page of the paper. So magnetic field, original magnetic field due to this current is into the page of the paper. Okay, how to do that? You point your thumb in the direction of current. Okay, then curl your fingers. Whatever is the finger direction, that is the direction of the magnetic field, right? Now if the magnetic field, original magnetic field is into the paper, now how the induced EMF will work? First of all, if the current is constant, the magnetic field is constant, so flux change is constant, so no flux changes, that means induced current will be 0. So third point is obviously incorrect, that is if current is constant, then there will be some induced current. So if the current is constant, no induction is happening. Now you have to understand that if the current is increasing, if the current I is increasing, then the induced current will oppose the original magnetic field. Okay, so if the current is increasing, the opposition means it's a circular coil, right? Circular coil, how to find the direction of magnetic field? You point curl your fingers along the circle and your thumb will point the magnetic field. So as I said, if the current is increasing, then current will be such a way that it opposes the magnetic field. That means the magnetic field will be out of the page. That means current will be AC/B if I is increasing. Okay, so if you see that only one option is given with increasing, that means if I is increasing, then along ABC. Okay, definitely this is not correct. Also, now let's see what will happen if the current is decreasing. If the current is decreasing, then the induced EMF will support the original magnetic field. So if current is decreasing in I, then this one will say, okay, you are decreasing, let me support you. So in that case, what will happen? The induced EMF will the current will be such a way that the induced EMF, the magnetic field, is in the same direction. Same direction means into the page of the paper, right? So in that case, the magnetic field, the current will be ABC. So current will be ABC if I is decreasing, right? It will be along ABC if I is decreasing. Option C is the correct answer. Okay, so this is a tricky question, but if a similar question comes, you have to understand that if current increases, then original magnetic field will be opposed. If current decreases, the original magnetic field will be supported. That is how you can answer if similar question comes in your board exam. Now 43, inductance of a coil is independent of geometry of the coil, medium inside the coil, current through the coil, the number of turns in the coil. So inductance L, okay, is mu naught A N, and there are some terms, but inductance of the coil is independent of the current. There is no current involved in this case. It is dependent on the geometry, that is, it is dependent on the area, it is dependent on the number of turns, obviously, it is dependent on the medium inside. Okay, if you change mu naught means when there is nothing. If you change something else inside it, then you have to multiply with the term mu r, that is relative permeability. So it is dependent on the medium inside, but it is independent on the current. So inductance of a coil is independent of the current flowing through it. More the current, it will oppose it more, but inductance will be constant. Inductance does not depend on the current. The phenomena of induction of an EMF in a coil due to change in the current through the same coil is called. So we have a coil, the current induction happens when current changes through one coil only, and that is called self-inductance. So this is called self-inductance or self-induction in this case. Match the column. One with the appropriate option in option 2. Now it is a four-way column. So let's see. Self-induced EMF. Self-induced EMF is called back EMF. Okay, self-induced, only one induction, that means it is a back EMF. Let's see. EMF induced in a rod moving in a magnetic field. So EMF induced in a rod moving in a magnetic field is a motional EMF. So this will be motional EMF. Now AC generator works on the electromagnetic induction by changing orientation of the loop. Okay, so AC generator there is a loop which is rotating in a magnetic field. Because of the change in the orientation, magnetic flux changes. That is why the current is induced. Now transformer works under the mutual induction. So these are the all options. So A with S, B with P. So again, if you see that A is with S, B with P, both of them have, so the first two matches are same for both cases. Okay, now AC generator, C is Q in this case, and D is R, so D is R in this case. Okay, so option A is correct. Now if you do the last match first, that is transformer, then that will give you, okay, D with R, then definitely there is only one match possible. So that is one another way to do it. Even if you don't know anything, if you know that transformer works under the principle of mutual inductance, you can still answer this question without any thought. Now consider the following two statements. Statement 1, when two coils are wound on each other, the mutual induction between the coils is maximum. Okay, so if you wound one coil and another coil over another, then definitely, because they are very close to each other, whatever flux is coming out of the first coil is linked with the second coil, no flux leakage, so mutual inductance is maximum. Second is, mutual induction does not depend on the orientation of the coils between the two statements. Now mutual induction definitely depend on the orientation. That is why mutual induction is maximum when they are wound one over another. Okay, so between these two statements, statement 1 is true, statement 2 is false. So statement 1 is true, statement 2 is false. Okay, mutual induction does depend on the orientation. Next question. Now we have moved into the another chapter, alternating current. So alternating current, one question and no horse question. So this is an easy question in terms of MCQs. Let's see. Use of laminated core in a transformer reduces energy loss due to eddy currents. Okay, so we use laminated core to reduce eddy current. This is the easy common known question. The frequency of AC is increased. The impedance of the series LCR circuit continuously increases, continuously decreases, first increases and then decreases, first decreases and then increases. So impedance is basically, what is impedance? Impedance is square root of R square plus XL minus XC whole square. Now if you start increasing the frequency, say from 0, what happens is that slowly the impedance decreases. Okay, so impedance decreases because current in the circuit increases. Current in the circuit increases, then it becomes maximum, then it reduces. Okay, so this is the current diagram. So this is for current. Now if current is increasing, that means what? If current increases, that means the impedance shall decrease. So impedance is decreasing like this, and then at this point both of if current is maximum, impedance is minimum. Okay, then again it is increasing. So this is called resonance diagram. So we know that resonance happens in an AC circuit, LCR circuit. So impedance basically decreases initially, then it increases. So first decreases, then increases. Option D is the correct answer. Next question. Power factor of a purely resistive circuit. Power factor of purely resistive circuit is 1. Okay, cos phi is called power factor, which is equals to 1. Okay, for purely resistive circuit it is 1. For pure capacitor or pure inductor it is 0. Okay. At resonance, a series LCR AC circuit behaves like a pure capacitive circuit, pure resistive circuit, pure inductive circuit, LC circuit. As we just discussed that at resonance, resistance is minimum, XL and XC, they becomes equal, they cancel each other. So it just behaves as a purely resistive circuit. Okay, at resonance you also remember that the impedance is equals to the resistance. Okay, let's move on. The power factor of a series LCR circuit is maximum when XL equals to XC, XL greater than XC, XL less than XC. Okay, power factor is maximum. Power factor means again that same question, cos phi is maximum. Maximum value is obviously 1 when it is at resonance, right? Cos phi becomes 1 when the circuit is purely resistive. That means it is at a resonance, that is XL equals to XC. Okay, next question. Which one of the following statement is wrong? AC can be easily and effectively stepped up or stepped down. Correct statement. It is economical to transmit DC over large distances. This is an incorrect statement. Okay, it is economical to transmit AC over large distances because you can easily step up or step down. Okay, you can send a very high voltage with very small current in a long distance so that the power drop is small. power loss is small. That is why it is economical to send AC over large distances. So this is the wrong statement. This is your answer. The average value of sinusoidal alternating current or voltage over a complete cycle is 0. The average power consumed by an AC circuit over a complete cycle may not be 0. So these are all complicated question. So average power consumed in an AC circuit may not be 0. Very important. People might think that average power consumed will always be 0, but no. If the circuit is resistive, then average power consumed will not be 0. If it is only inductive or capacitive, average power consumed will be 0. So be very, very careful. The phenomena of resonance exhibited by an AC circuit if both L and C are present in the circuit, if only both L and R are present in the circuit, only if both R and C are present in the circuit, only R is present in the circuit. So phenomena of resonance is visible only when L and C both are present. Okay, only R, only L, only C, or any combination of R with L or C is not required. Only L and C are compulsory for resonance. Okay, the dimensional formula of LC is, so what is LC? L is obviously inductance, C is capacitance. So frequency is basically, the resonance frequency is 1 by 2 pi square root of LC. Now frequency means what is time period? Time period is 1 upon frequency, that is 2 pi square root of LC. Okay, now time period means what? Time period means time, right? So time is, the dimension will be time. That should be the dimension of square root of LC. Okay, 2 pi is the dimensionless. Now if you square both sides, then you will get LC is basically T square. So dimension of LC is T square. So option B is correct, not T to the power minus 2, it will be T square. Okay, easy but slightly understanding based question. Now EM waves, again if you see EM waves, one question is coming, very easy chapter and no hot question from this chapter as well. So mostly memory based questions will come from this chapter. Displacement current is produced due to constant electric field, constant magnetic field, changing electric field, changing magnetic field. So obviously changing electric field is the answer. Displacement current is produced by changing magnetic field, no changing electric field. Now this question is last year's question, so most probably will not come again. The expression for the displacement current is ID equals to epsilon naught d phi E by dt. So don't confuse with this term. Okay, mu naught is generally there in the expression, but mu naught comes due to the fact of Ampere circuital law, which says it is basically mu naught into I. From there this mu naught comes in the expression for modified Ampere's equation, but ID will always be epsilon naught d phi E dt. Choose the false statement. Electromagnetic waves are produced by accelerated charged particles. Correct. For electromagnetic waves, E naught by B naught equals to C, where E naught and B naught are electric and magnetic field amplitudes. Correct. Electromagnetic waves are transverse in nature. Correct. Electromagnetic waves can be deflected by electric and magnetic field. No, they cannot be deflected by electric and magnetic field. So this is a wrong statement. So this is the correct wrong statement. Okay. Which electromagnetic wave used in long range communication? So in long range communication, what we use radio waves. Okay, so radio waves are the waves that is used in the long range communication. Okay, something happened, let me check. Okay, radio waves are used in long range communication. Let's see. The increasing order of wavelength of infrared, microwave, ultraviolet and gamma rays. Okay, so increasing order of wavelength, that means first we will have to identify which one has the smallest wavelength. So gamma ray has smallest wavelength. Okay, gamma ray is smallest wavelength. This is symbol for gamma. So gamma has smallest wavelength. Then next is ultraviolet. Ultraviolet has the second smallest wavelength. Next is infrared. Infrared is after visual, right? Last is micro, and then it is radio. Okay, so gamma, ultra, infra, micro. So option B is correct. Okay, Speed of light according to Maxwell's equation is given by C equals to 1 by mu naught epsilon naught square root. Okay, so this is the answer for this. Next is ray optics chapter. So we are moving quickly because all of them are easy chapters. So again, one question expected, no HOTS question from this chapter. The speed of light in a medium depends on angle of incidence, angle of refraction, refractive index, its mass density, obviously not mass density, obvious question. For total internal reflection of light, light should travel from rarer medium to denser medium, right? Is it right? No, right? Light should travel from denser to rarer medium. Okay, from water to air. Okay, so easy question. Next, Snell's law fails in the case of when snail is walking on the beach. No? When light travels from denser to rarer, oblique incidence. When the light travels from rarer to denser, normal incidence. So when the light is falling normally, normal incidence means when the light is falling along the normal. This is called normal incidence. Okay. And some time back some student asked me, sir, what is oblique incidence? Oblique incidence means when the angle is not other than normal. Okay, so in case of normal incidence, angle of incidence is 0. Okay, any other value of incident where I is not equals to 0, that is called oblique incident. This is called oblique incidence. Okay, so if you have any doubt in a language, this is the perfect way to remember it. Next, the principle of optical fibers is reflection of light, refraction of light, dispersion of light, total internal reflection of light. So fiber optics works under the principle of total internal reflection of light. That's how the data is transmitted. The focal length of a lens depends on refractive index of the material, radius of curvature of the surfaces, diameter of the aperture. So what is the lens maker's formula? Lens maker's formula is n minus 1. Normal for air we are considering 1 by r1 minus 1 by r2. So definitely, as you can see, it depends on the refractive index, it depends on the radii of curvatures, but there is no diameter of the aperture, so option 3 is this option 3 is not correct. So only option 1 and 2 are correct. So only option 1 and 2 are correct. 3 is not related. Next question. Two thin lenses of focal lengths f1 and f2 are in contact. The power of the combination. So two thin lenses are connected one after another. So power will be p1 plus p2. That is 1 by f1 plus 1 by f2. That is f1 plus f2 divided by f1 f2. Okay, this is the power. So f1 plus f2 divided by f1 f2 is the power. Common focal length will be in reciprocal of this. So this is focal length, this is power. The angle of minimum deviation of a prism depends on only on angle of prism, only refractive index of the prism, angle of incidence, both angle of the prism and its refractive index. So definitely angle of minimum deviation, if you remember the formula, refractive index is given by sine A plus delta m by 2 by sine A by 2. So if you see that these three quantities are related, so any one of them is related to other. So now mu and A are constant. Okay, so mu and A for a given prism is constant. So delta m basically dependent on A and mu. Okay, so delta m is fixed for a given material, given prism, because mu and A are constant, right? So it depends on angle of prism as well as refractive index. The magnification of a refracting telescope is given by FO by FE, focal length of objective divided by focal length of eyepiece. Now next chapter, wave optics. Now this is again one question is coming, but 1/3 chance of a HOTS question. So one of the three blueprint is saying that from this chapter there will be a HOTS question. So we will study mostly easy question and 1 or 2 difficult questions in this set. Two light sources are said to be coherent when both the sources of light emit light of the same amplitude and phase, same intensity and wavelength, same speed, same wavelength and constant phase difference. So phase difference is very, very important for coherent sources. So phase difference, they should be phase locked, okay, and wavelength should be same. That then only we will say they are coherent sources, okay. What would be the resultant intensity at a point of destructive interference if there are two identical coherent sources of intensity I naught producing an interference pattern? So at the destructive interference, if both of them are I naught, then the resultant intensity will be I1 minus I2. There is a formula also, but it will be 0 in case of both of them are equal intensity, and for a constructive interference, basically it is there is a square here. Okay, this is the formula. Now in case of constructive interference, it will be I naught plus I naught. Generally, if I naught and I2 are not same, then this is the formula. So it will be 2 root I naught whole square, that is 4 I naught. So 4 I naught is for constructive interference. Okay, for destructive interference it is 0. A beam of unpolarized light of intensity I naught is passed through a pair of Polaroids. Very, very important. A pair of Polaroids with their pass axis inclined at an angle of theta. The intensity of the emergent light is equals to. Now this is a trap question, HOTS question. So first there is a Polaroid P1. There is a second Polaroid P2. The angle between their axis, pass axis, is theta. Okay, so you will say, sir, I naught cos square theta. Okay, no, wrong. So when the intensity of the incident light is I naught, when it is falling on the first Polaroid, after it is getting polarized, the intensity becomes I naught by 2. Okay, many students often ignore it. Now once it is passed through this, and again when it is passed through the second Polaroid, then it will become I naught by 2, that is this value into cos square theta. This is Malus law. Okay, so I naught by 2 into cos square theta is the answer. Okay, so this is very, very interesting question. Based on this, even KCET questions also comes, but that will be little longer, little complicated, but don't worry about it, we will solve some questions on that also. But this is a very, very, very common and important question. When a point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wavefront. So we have a thin convex lens and a light source, point light source placed at the focus. So what will happen to this light? The light rays, after falling on the lens, what will happen to them? It will become parallel. So parallel light means what will be the shape of the wavefront? Shape of the wavefront will be plane. Plane wavefronts. Okay, it will be plane wavefront. Okay. Next, shape of the wavefront for light coming from a distant star. So light coming from a distant star, again they are parallel. Parallel ray means they are always plane. Okay, plane wavefront. Okay, different examples. We will have constructive interference if the path difference is delta x equals to n lambda, delta x equals to n plus 1 lambda by 2, n plus 1 by 2 lambda, n minus half lambda. So constructive interference is when it is integer multiple of lambda, wavelength lambda. Two lights of intensity I naught are used in Young's double slit experiment. The intensity of the interference maxima is 4 I naught. Okay, the same question we have solved for minima there. It is maxima, constructive interference or maxima, destructive interference or minima. Okay, so maxima or constructive interference are same, minima or destructive interference are same. Next question. Now we have moved into dual nature of radiation and matter. 24 questions more left. Again No hot question from this chapter, only one question coming from this chapter. So light of certain frequency and intensity incident on a photosensitive material causes the photoelectric effect. The incident of radiation is made exceedingly dim. So if you dim the intensity, definitely the photo emission will continue, but saturation current will decrease. Okay, photo emission will continue, saturation current will decrease. Saturation current is directly proportional to the intensity, but photoelectric effect is independent of the intensity, so it will not matter. Okay, next, the de Broglie wavelength of a moving particle is independent of the charge of the particle. Okay, de Broglie wavelength is independent of the charge. Next, emission of electrons from a metal surface by heating is called photoelectric emission, thermoionic emission, field emission, secondary emission. So by heating means thermal, so thermal means thermoionic, obviously. Okay, the name itself is giving you the answer. The photoelectric effect experiment if only the frequency of the incident radiation is increased. Okay, so photoelectric effect experiment if only the frequency of incident radiation is increased, then the maximum kinetic energy of photoelectron decreases. No, maximum kinetic energy will increase. The stopping potential increases. Stopping potential is basically maximum kinetic energy. So if maximum kinetic energy increases, stopping potential increases. So this is the correct answer. Photoelectric current decreases, photoelectric current decreases. Photoelectric current is independent of the frequency, it depends only on the intensity of light. Okay, whereas the stopping potential, the maximum kinetic energy, they are dependent on the frequency. The sufficient energy by the electron to overcome the attractive pull of metal surface. So sufficient energy to overcome the attractive pull is called work function. Okay, not binding energy, not stopping potential, not field emission. It is called work function. In a photon particle collision, which of the following is conserved? So in photon particle collision, everything is conserved, kinetic energy as well as momentum. Okay, so total energy and momentum are conserved. So total momentum, total energy. Next, the gathering of and focusing of mechanism of light by the eye lens is described by, so this is a part, it is dependent on wave nature of light. The visualization of color by rod and cone cells, that is dependent on the wave nature of light. If you have read NCERT, you know the answer. Now again, atoms chapter, there is a chance some of the blueprint, one blueprint I think they are saying that there will be 2 questions from this chapter, and again 1/3 of the one blueprint is saying there will be a HOTS question from this chapter. Okay, we will see some questions from this chapter as well. The condensed matter and dense gases at all temperature emit electromagnetic radiation due to high temperature, oscillations of atoms and molecules, head-on collisions between atoms and molecules, none of this. So condensed matter and dense gases at all temperature emit electromagnetic radiation, because what happens is that they oscillate at high temperature, and oscillation means there will be electrons moving out and coming back. So it is oscillation of atoms and molecule. Atoms and molecule oscillate. Oscillation means radiation of energy. Okay, collision does not give rise to electromagnetic radiation. Okay, oscillation means acceleration, right? Now according to classical theory, statement 1, the electron will fall into the nucleus. Yes, an accelerated electron emits radiation in the circular path. Yes, that is also correct. Both statements are correct. In fact, because accelerated electrons accelerate, it is radiating energy, that means it is losing energy, and that is why it will fall into the center of the nucleus. So both statements are true, and 2 is the correct explanation. So option A is correct answer. Next, from kinetic theory, the size of the atom was known to be 10 to the power of minus 10 meters. Okay, size of the nucleus is 10 to the power of minus 14, approximately minus 15, minus 14 to minus 15 meter, whereas the size of the atom is 10 to the power of minus 10 meter. The minimum energy required to free the electron from the ground state of hydrogen atom is called. So if you want to free the electron, that means you are completely taking it out of the atom. That means 13.6 electron volt you are supplying. So if you are very good in chemistry, then you should know this value is particularly called ionization energy. Okay, it is not excitation energy, it is not zero potential energy, it is the ionization energy. So if you give this energy, the electron will be free. So free the electron, the energy given is ionization energy. The alpha particle are nuclei of helium atom. Okay, alpha particles are nuclei of helium atom. This is itself is alpha particle, but this is not the nuclei. This is itself is the nucleus. Okay, alpha particles are nuclei of helium atom. Next, the negative sign in electrostatic potential energy of an electron signifies that potential energy of an electron is unstable, electrostatic force is in the negative r direction, kinetic energy of the all electron is constant. Okay, so electrostatic force in the negative direction, that is the negative sign of electrostatic potential energy means. Also it means that you have to provide energy to free the electron. Okay, so there are two explanations to that. Negative energy of potential means force is acting in the opposite direction to the displacement. Okay, and that means electrostatic force in the negative direction and compared to r, and other than that you need to supply energy to free the electron. That is also a reason. Now next, second last chapter, nuclei. Isotones are atoms, not isotopes. It is isotones. Isotopes are basically same number of protons, different number of neutrons. Okay, isobars is same mass number. If mass number is same, they are called isobar. Okay, isotones is opposite to that of the isotopes. Same number of neutron but different number of protons. Okay, so same number of neutrons but different number of protons are called isotones. Okay, so there are three things you have to remember: isotones, isotope, and isobars. And this chapter is easy question, so there will be highly possible that there will be an easy memory based question. The radius of a nucleus of a mass number A is directly proportional to A to the power 1/3. Okay, radius is always proportional to A to the power 1/3. Okay. Which of the following is correct for nuclear forces? Short range, attractive, and charge independent. Short range, attractive, and charge dependent. Long range, repulsive, not long range. So nuclear forces are always short range and it is charge independent. So option A is the correct answer. Long range, as soon as you can see long range, you can ignore those options. Binding energy of a nucleus is energy given to the nucleus during its formation, the total mass of the nucleus converted into energy units, energy required to break the nucleus into constituent nucleons. Okay, so energy required to break the nucleus into constituent nucleons is called binding energy. Next, the binding energy per nucleon is maximum for iron. Okay, binding energy per nucleon, if you see the binding energy graph, it gives you a peak at the near iron. So iron has the maximum binding energy per nucleon. Okay, next, radioactive substances emit alpha rays, gamma rays, beta rays, all of the above. They emit all types of rays, so all of the above. Now last chapter, semiconductor, again another easy chapter. Okay, no HOTS question from this one. Question will definitely come. So 1 means one question will definitely come. So as you can see, there are 14 chapters, 14 questions will definitely come, one question from each of the chapters. There are few chapters from where you can expect the second question, that is the 15th question. Okay, so 14 chapters, 14 questions, but you have to answer 15 questions. So one question will come from some chapter, there will be 2 questions. Okay, so according to the blueprint, I have taken which are the chapters from where you can expect 2 questions, and if 2 question is coming from a chapter, then definitely the second question will be a HOTS question. Okay, so if there are 2 questions coming from one chapter, that means one of them will be easier, another will be HOTS question for sure. Okay, the valency of impurity added to silicon crystal to convert it into a N-type semiconductor. So N-type semiconductor means it is giving electrons, so that means it will have one extra electron. Silicon is a tetravalent material. Tetravalent means valency 4. Whoever is coming to silicon to make it N-type, that should have extra valency, that means it should have one extra electron, so valency should be 5. Next, the majority charge carriers in a p-type semiconductor. In a p-type semiconductor, majority charge carriers are holes, okay, and minority charge carriers are obviously electrons. Semiconductor doped with the donor impurity. Donor impurity means who is giving, who gives only in N-type semiconductor, the donor impurity gives one extra electron, that is why they conduct. So it is an N-type semiconductor. In case of P-type semiconductor, it is an acceptor dopant. Acceptor dopant takes electrons so that more number of holes are created, right? So semiconductor doped with donor impurity are N-type semiconductors. Next, the cut-in voltage for a silicon diode approximately. The silicon diode cut-in voltage is approximately 0.7 volt. Now cut-in voltage and the band gap are different. Band gap is 1.1 electron volt, whereas cut-in voltage is 0.7 volts. Okay. PN junction diode is used as an amplifier, a rectifier, an oscillator, and modulator. It is used mainly a rectifier. In a semiconductor, the construction of electrons is concentration of electron is 8 into 10 to the power of 14 centimeter cube. Here it is 5 into 10 to the power 12 per centimeter cube. That means what you can see that electron density is more than that of the holes density. So electron density more than holes density means it will be definitely an N-type semiconductor, right? Now last question, 101th question, we generally don't give 0 at the end, that is why 101th question, which of the correct diagram is a half wave rectifier? So half wave rectifier is basically this one, okay, this one is a half wave rectifier, this one is a full wave rectifier, okay, these two are just garbage pictures, okay. So now we have reached at the end, and let me know if you have enjoyed this session and whatever doubts you might have. Also, I'll be doing a live today around 11 AM. So I hope I will see you there with all 25 numericals I'm going to solve and some important formulas. I'll be explaining it to you to remember. So I'll see you there. Till then, bye.